how fast was this thing shot?
Okay, now it's a distance. It's traveling a longer distance, the arc path is longer,
Yes, absolutely.
but they hit at the same time, so velocity of the arc one's gonna be higher.
Yes.
Okay.
But the key thing here is that the times are the same. And that is the part that we will exploit.
Right. Okay.
So faced with a problem like this, we need to figure out what the positive directions, plural, are. So,
Not this, the right.
there we go. Thank you. This is my positive directions. I'm gonna call it I hat, J hat, although often in problems like this, I just call them the positive directions. Using I hat, J hat, this will become more convenient when we get into chapter 4. And I'm gonna treat this like two separate problems, because again, they fill at the same rate, so all I wanna do is figure out, based upon if I dropped it, how much time would it take to hit the ground, and I'll use that time for the horizontal motion. So I got my 5 basics here, the S, the I, the F, or X, or S, or whatever you like, A, and T. I'm gonna do my I hat direction, or horizontal, and then my J hat, or my vertical. And one time to bind them. All right, so what do we know?
Starting velocity? The initial velocity?
I got 2 initial velocities. Which one? Or,
There's 0 for both, right?
and then I'm trying to find this one. I'll just call this something clever like a V. What else do we know?
We know the J hat acceleration,
Is
negative 9.8.
in the horizontal?
I guess it's the same thing, right?
No,
There's 0 acceleration in the
Zero.
horizontal?
0.
Why is it 0? Because
Because once it's in the air, it's already been launched. I'm not worried about the acceleration while it's being launched, but once it's launched, the only force acting on it is the force due to gravity, which is down. There's no horizontal forces acting on it, because we're ignoring air resistance. No horizontal forces acting on it, so the acceleration is 0.
You know the displacement?
Okay?
It's 2 meters in the vertical and 4 in the horizontal.
What's wrong?
sides,
Negative.
they're both negatives, yeah.
Not both negative. The way I've drawn it is that the horizontal displacement
Yeah,
is
yeah.
positive.
Sorry.
Probably the biggest mistake I see on people on these problems was mentioned earlier, having 9.8 meters per second squared as the acceleration, positive or negative, but the biggest mistake is assuming that's the acceleration for the horizontal. It's not. So I don't have enough information over here on the horizontal, because I only know 2 things, but I can find the third thing using my vertical information, because I have 3 things here for vertical, and I can use that to solve for time. And the 4th equation down there. Negative 2 is equal to 0t minus 4.9 t squared. And negative 2 divided by negative 4.9 is equal to t squared, and t becomes the square root of 2 over 4.9. Someone's gonna tell me what it really is.
No, it was 3.
I don't know how your head does that. Like how you can do square roots in your head that aren't like even ones.
Well, 2 over 4.9 is roughly 0.4. That's like 2/5.
Okay.
And so what times what gives me 40? Well, 6 times 6 is 36, so it's something bigger than 6. And then there's obviously some guesswork there. All right, so I have the time now for both of them, because the thing's in the air vertically just as long as it's in the air horizontally. And I've tried to think, is it possible, even when you get to quantum physics and suddenly everything gets thrown out of whack, is it even possible there that the times would not be the same? And I don't think so. So the time is going to be the same, 0.638 seconds, or 0.638 seconds. 0.638 seconds. And then down those three things over for horizontal, and the same equation. 4 is equal to VT plus 0. Technically 1/2 times 0 times time squared, but oh, we know what T is. So V is equal to 4 divided by 0.638. Sure, it's not 6.38.
269.
269.
Meters per second.
All right. Now, Michael, you're looking at your calculator like you're trying to, something's off.
I was just looking at the rounding, because it's 2695, so you would either have to do 2696 or 27.
It's 5 something.
It's 59 after that, so.
Now, quiz or test, I'm not taking off for that. That's a lab thing where I would take off for that. Since labs has a lot more emphasis on detail. All right, so we have 6.27 meters per second is how fast the thing is shot. Obviously, I'm about to make it more complicated. Questions on this one before I go ahead and make it more complicated? All right. Now there are other variations of this exact same problem. I could have told you the time and not given you the height, and it's just a matter I could give you one other piece of information and not tell you another. But Dan?
You don't find the final velocity?
Oh, let's go ahead and do that.
You don't have to.
No, actually, there is an important piece here, because that's the kind of thing I would ask on the test, just assume, oh, well, we didn't do it in class, but they know how to do that stuff. So I'm going to just go ahead and do that. There's no change in my horizontal velocity. There's no acceleration horizontally, so I've got the horizontal component done. The vertical component, well, that's just a matter of, well, I need to find this, and I have, well, 4 other pieces of information. I would prefer not to use this one just because that's rounded off. So I would use number 2. So I have 4, nope, I lied on that one. I have VF squared is equal to 0 plus 2 times negative 9.8 times negative 2. Nope. It's going to be somewhere around 6.38. -6. So the speed is 6.26 meters per second, but we're finding final velocity. So my final velocity is negative 6.26 meters per second. So now, what is my final velocity? I haven't actually answered the question yet because I found all the pieces, but I haven't put it together. So my actual final velocity, well, now it's really convenient. If I had J hat there, it's going to be it's listed the exact same thing, that's a strange coincidence. 6.27 meters per second squared I hat minus 6.26 meters per second j hat. There's rectangular form, done, don't really need to keep going unless it's specified. Textbooks might, sometimes they'll go, what is the final speed, and what is the, and what angle does it hit, which is just basically asking you for polar form. I do want to at least set up the next problem. I realize we're short on time here. So I'm gonna set up the problem and leave it as a cliffhanger. An object is propelled at an angle of 30 degrees above the horizontal at 50 meters per second from a cliff of a height of 20 meters. Ground below is level. Where does it hit? We're gonna do a very similar process to what we just did. We'll set up our 5 criteria here. We'll write in their H and our horizontal and vertical parts of what we'll know. We'll use the vertical in order to find time. We'll use that in order to find how far it goes out horizontally. The only difference is now we're gonna have to use quadratic formula. I guess quadratic formula is gonna be the simplest way of getting the time. But we've done that already a couple times. We're good to go. Another ball bearing somewhere around. Did I put it back? Hey, see it?
I don't know, man. I have an Instagram. I'm gonna DM him.
Yeah, cause remember for the lab, he has a thing, and
Yeah.
I mean, like, we all have the work, and we can do it real quick. I'm probably gonna do it, cause like, we need to know if we can turn that in.
Okay, I'll message him, yeah.